And you'll all have these questions. This is my contact info if you would like to reach me by email or any of these social media channels. Oh, I have a Threads account. Yeah, Instagram and Threads are the same account. So trying to use things besides Twitter, since Twitter's a little strange these days, more and more. So today's talk is called 7 Strategies for Building Majestic Monoliths. And the notion of a majestic monolith came from David Hannemeyer Hansen. He's the guy who created Ruby on Rails. If you have used Ruby on Rails before, I have used Rails before. I like it as a framework, and I've always found his work interesting. So I follow his blog. And the point he made in the Majestic Monolith, I mentioned earlier when the idea of microservices came out, I was really intrigued by the idea and jumped into building microservices and patterns around that really early on. And I came across his this blog post called The Majestic Monolith. And the gist of his blog post was people kept asking him when he would refactor his applications. He owns a SaaS company, right, that makes a few different applications. And people kept asking him if he was going to, or when he was going to refactor his monolith into microservices. And his answer was that he was not going to do that at all because they went to production every Friday. And he said, in his company, getting an idea from accepted to production in 5 days is plenty fast enough. And so he didn't want the overhead and the headache that would come with a distributed application when he wasn't going to receive a lot of benefit from that. So I thought this was a really great idea. At Red Hat, I talked to a lot of different customers or a lot of people in a lot of different organizations, and I knew a number of different teams who had experienced some pretty significant pain by moving to a big exploded distributed architecture. And so I was also, as I remember reading even in the initial blog post from ThoughtWorks, where the phrase microservices was coined, one of the things that Martin Fowler talked about was that you shouldn't start with microservices. You should start with a monolith. So I like the idea of starting with a monolith, but building that monolith in a way that you can later pull parts of it out. And that was a second blog post by Hannemeyer Hansen called the Citadels and Outposts pattern. And that's when you can pull apart part of your monolith and create what he called an outpost. Sometimes we call this strangling the monolith. I think that term is usually used to like legacy applications. So what we're talking here, or what I'm going to talk about here, is very intentionally building a monolith that you can refactor if you need to. One reason this comes in handy is we often talk about building microservices so we can get features into production faster. That's absolutely a valid reason to build microservices so you can deploy, at different times and at different speeds. But another reason is when you need to scale a specific part of your application. So if you have one piece of functionality that takes up a lot of resources while the rest of your application doesn't, you can break that out and scale that on its own. So these are some things you can do to make your life easier if you are taking this approach. We're going to talk about code quality, continuous delivery, coding to APIs, autonomous data. In a microservices world, all microservices are supposed to own their own data, and that's often one of the biggest problems. Avoiding bottlenecks, right? So how do you make your applications more performant, especially as they're distributed? Domain-driven design and bounded contexts. And this is probably the biggest part of the talk, or at least the most complicated bit of material. I'm really glad, hopefully, that everybody watching saw the excellent hexagonal architecture talk earlier, because that dovetails nicely with DDD. And that was a really, really good talk. And then at the end, we'll talk about, I'll conclude by talking about citadels and outposts, what to do when you want to extract a microservice from your monolith. All right, so first things first. So code quality. Code quality is easiest to bake in right from the beginning of your project. There's lots of different plugins you can use in the Java space and other spaces too if you're not coding Java, but you can wire this stuff inside of your Maven build. I've got one example. One thing I like a lot right here is Jacoco. My application is built using Quarkus, and so I can pull Jacoco in really nicely. There's a plugin here. Where's my, so right here, I can add a plugin into my POM. And then when I run Maven verify, it's going to run a report and it's going to create a report inside my target directory. Let's see, I've got a tab of that report right here. So this is what it's going to give you. If you're not using this kind of stuff, just throw Jacoco into your Maven file. There's others, PMD, Project Mess Detector. There's all sorts of different things that you can run against your application. This one's just really, really simple and easy to get started. And what it does, this gives you a drills in detailed into your code and shows you where you're missing test coverage, right? So two of the items in this class have coverage and one of them doesn't have any coverage, right? It even gives you highlights, right, for exactly what is being covered and what's not being covered. As I said, there's lots of different tools. This one, I think Jacoco is really great. Shows you what your test coverage is. I'm really big on having tests, having unit tests and having test coverage. So I like this a lot. But there's certainly more complicated stuff that you can also pull into your project. Personally, I don't like to fail builds. Some people would fail a build if you don't pass a certain level of coverage. I think it's better just to kind of look at, and projects are different and certain things are different. I don't really care if getters, are covered here. But you do want functionality covered, right? So if you have real functionality, this is definitely something to go through as you're refactoring your code, as you're doing a code review to look through. And what's going to be making it important is that way when we start breaking pieces of the application out, we know we're still passing our test case and we know we're safe. All right, so number 2 is continuous delivery. Now, I said continuous-ish delivery here because most enterprises won't really commit to continuous delivery. A lot of startups you push to production all the time or hundreds of times a day or dozens of times a day for certain projects. A lot of times in the enterprise that isn't reasonable. What I do think, though, is it's really good to be able to go to production at any point in time. So I do think you should build on every single commit. A lot of different ways to do this. There's all kinds of tools. I like using GitHub Actions, right? Started using those. And GitHub Actions, if you haven't seen a GitHub Actions before, they're really, really simple. You just add this GitHub Workflows folder inside of your directory, and then it's an Actions, it's a YAML file, and you build jobs, and you can find these jobs. They're really easy to set up. You can grab other ones, other existing jobs, and reference other jobs. And so I'm in here. I'm checking out code. I'm using JDK 21. I'm running a build, which is also going to run my entire test suite. I'm calling Docker to build an image, and I'm pushing an image to Docker Hub. So I've always got a latest image that's going to get built. And we can see the runs on here. Let's see. Yep. So you can see you can break, right? So and I get an email, right? So I get an annoying email. It's going to bug me, and you can hook this into all sorts of different things. But I think it's really important. Pick one of these things and be able to go to production at any point in time. That way, if anything goes wrong, you can always go back, right? But it's much better to catch things early. All right. So third, APIs first. Now we can get into some code. We can get into some fun stuff. It's been a long time ago. I live in Atlanta, and I used to attend the Atlanta Java Users Group every single month. Since coming to Red Hat, I travel a lot, so I don't get there every month. I'll be at their conference next week, though. I'm very much looking forward to that. Been to their conference now for, I think, 20 years, 21 years. Anyway, maybe it's been a good while now, but there was a presentation at AJUG once talking about user experience from a developer's point of view and from a consuming code point of view really changed the way that I wrote code. And one of the suggestions there was to provide an API package. Like in Java, that's really easy to do with an interface. Often when we talk about APIs, we're talking about REST APIs, right? Or we can talk about schemas for Kafka. But you can do this inside of your Java code as well. And I really like this approach. And let me show you my application here first. We should have started with that. It's always good to start the demo. So the application I've got here is called the Quarkus Coffee Shop. And I built this application sort of to just build a little thing with Quarkus. And I have this as a monolith and as a series of microservices. Like most coffee shops, right? We've got some drinks and there's some food stuff there. So there's a barista and there's a bakery. There's a little board here when we make an order. Let's order something. I drink black coffee most of the time. So great black coffee, and we'll just place an order. And this, let's place order. That should pop. There we go. So, well, one's already ready, so they already fulfilled one, and now they're both ready. So what goes on in the background here is I've got a web page. The web page is making a post request to a REST API, and then that is kicking off the order. The order is sent out to a bakery service, and the bakery service applies business logic, which in this case is just delaying a few seconds, and then tells then messages the front end. I'm streaming using server sent events to the front end that the drink is now ready. So I'll walk through this a little bit, and I'll notice how how the packages are structured. And one thing I have here is like for my barista, I have an API package here. Actually, all my packages have an API package, and so I've got this barista package, and this is a really nice way to look at. Don't worry about this Unity thing. I'll talk about in a moment. But I have methods like ticket in and remake, right? So these are the only things I'm really telling the barista is you have a ticket that's coming in, and a ticket is a ticket for a drink to make, and then you have a ticket that you need to remake. So this provides an API for anybody else who's going to come behind me and code towards this. All of the parts of the applications have this API. So my order service here, right? And can you guys see this okay? Is this, I can expand this a little bit more too. Hopefully this is a decent resolution. And so inside my order, right, there's order in, the order service needs to know when an order is up and when something needs to be remade, right? So these APIs makes it really easy to code. And the interface, another thing it can do is, this is all public, right? It's an interface. And then I have an implementation class, which is going to have some public stuff, but I can also put private methods in here. I can put package private methods in here, but it allows me to control what functionality goes across the rest of the application. So APIs, really great to have APIs and to document your REST APIs, but it's also good to have APIs for inside of your code, right? People are going to read your code. They're going to come behind you more often than you're going to write it. And this makes it extensible even when you're working inside of Java libraries. And then other rules around writing decent APIs. I'm trying to keep my eye on time too. I know we're running a little bit over. All right, fourth is autonomous data. So in the world of microservices, people talk a lot about how microservices should have their own database. This is often one of the most difficult things to do, especially if you're talking about extracting a microservice out of an existing legacy monolithic application. It becomes very difficult to do. I remember seeing Neil Ford present a year or so ago, and he said that one of the things ThoughtWorks has done is they often sort of scrap that idea and just sort of understand that we're going to have one database. It's just the way things are. So if you're starting a greenfield application, it makes a lot of sense to, from the very beginning, decide that I'm going to parcel up my data into multiple places. So you can duplicate your data source. You can duplicate your data sources in your application, right? This is pretty simple to do. You can also just use different schemas, right? So if you notice here, I have schemas for like barista, for coffee shop, for kitchen. So these are all these various pieces of the application are recording things, but they all have their own separate data source. If we look inside the application here, the way that ends up looking is inside a barista, I just inject a data source here. And that's just the name of my data source. So this is a Quarkus convention, but you can do this with whatever framework you're using, right? But set up different data sources for your application so that when I put stuff inside of here, it goes inside of that data source. I think if we look at the, should be some drop create syntax here. So here, drop create this. It doesn't tell me what schema they're in. So anyway, when I spin this application up, I tell Hibernate to drop and create the table. So it's dropping the tables, but it doesn't give me the schemas. But barista ticket's in a different schema than coffee shop orders, and kitchen ticket is in a different schema than the other two. So everything has, from the get-go, its own database schema, which makes it much easier when you eventually do break things out into microservices. Do we have any questions right now or anything in the chat that I should address? All right, I'll keep going then. And again, feel free to interrupt. All right, so avoiding bottlenecks. So one of the things we can do, blocking code, right, can make it hard for us to scale. I mentioned earlier, one of the core reasons people use microservices, probably the most common, is to be able to get things into production much faster. But another reason is to scale, right? And so blocking code makes it harder for you to scale. So there's a number of different ways you can do this. One is you can use reactive programming. This can be a little bit tough. I'm going to look at two different approaches we can do here. So like if you're using Spring Reactor can provide reactive-based code for you. If you're using Quarkus, like I am, Small Rye Mutiny package provides that. So we can use methods like a uni with order up. Whoops. We can use a method called uni or multis, and that's a way to stream or to asynchronously execute this code. Let's take a look at what that would sort of mean here. Come over here in my order service, like if we have our remake here, I call barista remake, and this is reactive code, right? And it might look a little funny when you first start using it. In fact, usually the learning curve can be pretty big. But what you're doing here is this method remake. Let's go inside this method here. So the API here says uni ticket up, which what this means is it's going to return a ticket up, but it's going to run that on an extra thread and essentially send this callback when it's ready. So this is going to execute on a separate thread. Can make debugging a little bit difficult, right? But what we're going to do is you can also, in reactive libraries, you can chain things together. So I'm calling this remake. I'm sending a remake ticket command over to this method remake, and let's look at what this actually does. It's pretty simple here. I'm just creating a new ticket up and then I'm delaying it by a certain amount of time, right? And so the way this reactive code looks, I create a uni, which means I want a single result. I'm creating it from an item, which is a ticket up. It just means that this particular order is ready. And when that ticket up is created, I'm going to delay it by duration of milliseconds. And I have this calculate delay method, which just checks to see what I've ordered and applies a different delay to that time to that. What this does is this is going to execute on a separate thread. When it's ready, it will call it back here. And that means I can scale up this remake method a lot higher. So this is a void method. It also means I could return that back to the front if I wanted to. And my front is my web package. And I've got a remake API, right? So I can call remake and I can just call this as a void method and that all just gets taken care of on the back end. So you can use reactive code, you can use void methods, and void methods can be a little bit complex because you have to figure out, well, then how do I know when this thing is ready, right? So if we look at the UI, I'm told when this thing is ready. And one way we can do that, and this is a little bit tricky, this is a Quarkus specific thing, but Quarkus under the covers contains the Vertex toolkit. And Vertex has an event bus, not an old-fashioned style event bus, but it's got a very small, lightweight, in-memory event bus, and that allows me to pass messages asynchronously. So let's look. First way, let's you know what, I can set a breakpoint and step through this. Why don't we do that? Let's step through one case. Order service import. Not remake, we'll say make, step order up. All right, so let's run. We'll attach the process. And I want my monolith there. We're attached to the process so we can step debug through here and get a look at what happens when we order something. So let's say all right, so first thing that we get is I'm going to call my order service on order in method, right? So this is my REST endpoint, right? I've made a post this method order. Now I'm going to call my order service. You jump over to that thing. And so we've got this method on order in. I create an order, which is what I'm going to put in the database, and then I persist that order through a repository pattern. I'll get into why I'm using this pattern when I get to DDD. And then I loop through loop through the line items, which are the individual like, drinks or stuff, and I create a dashboard update. A dashboard update is a Java record that I'm going to use to update the front end. And I'm saying event bus publish web updates. And web updates is the topic, right, that the event bus is listening on. I'm just marshaling it to JSON too. Now, what this is going to do is it's going to publish this on this web updates topic. And inside my project, so this way I don't have to specifically call this dashboard API. So my web page is listening to a dashboard at an endpoint stream, and it's sending server sent events. I'm injecting an event bus here, and the event bus is consuming that web updates topic and just streaming those out to the front end application, out to my web page. So I can communicate asynchronously. I can also do this through the various objects. So let's go back. Oh, where we go. Let's go to our next one. So JSON. And now I'm calling my barista in, and I'm sending those tickets off to my barista. And then we'll get an order up here eventually, right? So that's one way that we can go about doing this. Another way we can do it is we can listen on events. So I could communicate with these other objects by using the event bus, which makes it even more asynchronous. And I'll switch this out when we pull our Citadel and outposts. When I pull out my outpost, we'll take a look at doing that just through the event bus. All right, so to sum up, avoiding bottlenecks, you can use reactive code. There's sometimes other things like an event bus. Another way you could do this would be, say, to use messaging. I think messaging in a monolith might be a little tricky, but certainly with microservices, you can use async, messaging like Kafka is really common. You can also use a database to do this, although a database is going to introduce a different bottleneck, right? So, number 6, and the QA. You got a question? Okay, so the question, when using reactive programming, do you think that should also be advisable to use R2DBC, for example? That way it's reactive to bottom. So I'm not familiar specifically with R2DBC. Is this a reactive database driver? So if you're not reactive top to bottom, you will need to deal with blocking code. In Quarkus, this is fairly easy to do because it mixes. Yeah, reactive database driver. Yep. So if you're not going to be reactive top to bottom, you need a way of mixing that. Let me jump back and I'll discuss that in a little bit more detail after I pull the outpost out, because actually we'll see an example of that. I'll change the code. So when we pull out the outpost, what I'm going to do is swap that barista out to talk to Kafka. And so we'll see some reactive code then. So I'll come back to jump to that. But it's a very good question. And yes, if you're not reactive, you need to figure out where you're going to block, right? And because especially reactive code is not going to like it when you do block, right? Is that another question? Okay. All right, so domain-driven design and bounded context. So this is kind of the biggest part of the talk, right? Domain-driven design. So there's a few things I like about the concept of domain-driven design. And I had read this. I mean, this is an old idea. I think this book's maybe 20 years old, or the idea is roughly 20 years old. And I had read about it a long time ago. But with the onset of microservices, domain-driven design began to be picked up a lot again, because people talked about microservices being a domain or being a bounded context. And but the same thing applies inside of monoliths. And if you're looking at the monolith, we saw some of the code, right? I've got these various bounded contexts in my app. I have a web, I've got a barista kitchen, I have a counter. Counter is named counter because one of the things you do in domain-driven design is you try to use the same language as your domain experts. And in this application, we're modeling a cafe. And in a coffee shop, what's the center of action, right? The center of action is the counter, right? That's where you make orders. That's where orders come from. It's where you go ask for, a remake if you need to. So the counter is kind of the center of action. And so since that was our domain name, we named it a counter. There's other things. too, like if you're out of something, in the restaurant industry, at least in the United States, in the restaurant industry, when you're out of something, you don't say that you're out of it. You say it's 86th. And so people will say 86, creamer or 86 brown sugar. And that means that you're out of that item. I don't know why for sure that is, but that's pretty universal. And so if you're going to build a domain with somebody who owns a restaurant, you would use the phrase 86. Like an 86 exception would mean that you're out of something. I really like this concept because one of the hardest things is communicating with business owners, right? I spent most of my career, I mentioned I started off as like a web monkey doing actual, like, front end stuff. But most of my career, I worked with line of business owners, right? And there's always that mismatch when you're talking to people who have, really deep business knowledge, but don't really know anything about Java, right? And Java coders who know a lot about Java, but don't necessarily know anything about the business. And so I really like this concept of, speaking inside of, bounded contexts and using domain language. Now, there's a bunch of other constructs that go around with DDD. So one thing, the easy thing to do with bounded context is to make your packages mirror your bounded context, right? So I've got in here, we already kind of looked at this, right? But I've got in here, Zoom. Okay, there we go. So in here, I've got web. I've got a kitchen. Um, I've got a counter, and the counter has an API. I've got a barista. Now, there's a couple of things. There's also a shared domain. And when you break things out into microservices, you don't want to have like a shared domain library because now you've got coupling between those services. Much prefer to like talk over something like, JSON or gRPC or something else. But when you're still inside of a monolith, I think putting your domain objects that are shared across all of these domains in a shared place is fine. I still have some domain objects that are not shared, right? But these things are shared across all of these various projects. And one thing they all have in common too, if we look at these, I'm using Java records for these. So these are all immutable. And this is one of the things that DDD also talks about is don't pass around mutable objects. If it represents a record in your database, you only want that access from one place. So for instance, this order gets put inside of a database, and inside my barista, I have a domain with barista ticket, and that gets persisted. But those don't get shared anywhere. The classes that are shared are all immutable representations of those classes. And that way, nothing can get monkeyed with in a package that I don't want that to happen. Things like item, this is just an item, right? So that's not really an object. But all of these, like ticket in, look, these are all Java records. Java records are a great thing to use for these. Oh, all right. Sorry, I've accidentally opened things in two windows. So anyway, all of these are Java records, right? And so they're immutable. Once it's set, it's set. But it makes it really easy to pass data back and forth that way. So you keep domain objects inside of a domain package, and it's okay, I think, to share your domain objects. But if it's something that really is important, it should go inside. It's unique only to a specific bounded context. Like the order that gets saved in the database only exists inside of my counter, right? My barista and my kitchen don't need to know about that kind of stuff. Another hallmark of DDD is that you put your business logic, and this goes back to the hexagonal architecture, right? So you put your business logic inside of your value objects, right? So when I have this value object of order, the stuff around how to create an order, what line items are, how I marshal these back and forth from a command that comes in. Commands are also a construct of DDD. Place order command, and that's what causes something to happen, right? So a place order command, if we want to see what that looks like, it's a list of items, it's a UUID from the front end, a list of items, and a name, right? And so all the logic around that is inside of this object. And what that means is you can then wrap a service object around it. And in DDD, a service object is going to orchestrate all the things that need to happen. And so on that order in method, what it's going to do is it's going to create a new order object, right? Because I need to create and store this order. It's going to persist it. And in DDD, you use the repository pattern. A lot of people are familiar with this, Spring Data repository, JPA repository, and, Quarkus makes it. I'm using Hibernate Panache, which is a Panache extension that makes this super easy to do. In fact, I can pop in. All I have to do to create a repository is that, and I get a whole bunch of different methods. So I call persist there, and this is orchestrating what happens, right? So I create an order, I instantiate that order, I persist that order, I then loop around the line items of that order, and I update the front end because in the front end in the hexagonal architecture, the ports and adapters, right? That front end is an adapter, right? So data came in from the front end and it's going back out, to a different API on the front end, right? So talk about, one port in and an adapter on the way out, right? And then I also send things to my barista to go handle that bit of business logic. So the service, wraps and orchestrates all that kind of functionality. And then and if I wanted to, I can adjust this and I could add a Kafka topic. So if I wanted to send this, instead of sending it to the barista directly, if I wanted to send it to Kafka, I could do that. But I want to keep all that stuff separate because the barista is a separate domain. All right, so DDD. How am I doing on time here? All right, quick. So let's go get back to normal size. Back and we'll wrap up and get to questions. So package structure, marry bounded contexts. I like doing a domain package and an infrastructure package and keep those things separate. QA, okay. It's wrong. All right, there we go. Chat, was there another? And then, okay, so second part, okay. So that, yeah. So this gets us to citadels and outposts, right? So my application is great. It's a huge success, but I need to scale up my barista, right? I make a lot of drinks. Kitchen's kind of busy, but this is mostly coffees. I make a lot of drinks. I need to scale up. I want to have multiple services, multiple barista services. So how would I do that? So part of this is the microservices Death Star, right? And people think about these millions of microservices, right? We're all working for Netflix and we have all these microservices. But what I'm talking about is extracting one microservice. So not really doing this, or maybe eventually extracting a couple. So the way we would do this, and because I've coded to APIs, let's take a quick walk again of what's going through here. So my API resource, right? That front end is going to post a message to this order endpoint, and I'm going to call order service order in. And I need my order service implementation. And when the order comes in, it's going to orchestrate some stuff. It's going to update the front end, and then it's going to call barista ticket in. And this is an API, right? Just a void method of ticket in. So let's say, right now, the functionality is happening inside my barista package over here. But let's say I want to change that out, right? Say I don't want to do that anymore. So let's look at my barista implementation here. And right now, my barista implementation, is executing everything. I'm really happy with me zooming, but it's executing everything in line, right? So a ticket comes in, it's recording how long it takes to make the ticket, and then it creates its own domain object, persists that to its own schema, and then tells my order service that the order's up. So we're going to change that now. Let me just comment this out. Close it there. And I'm going to make a couple of changes here. So I've already got Kafka as part of this application. I have Kafka running, and I'm going to do, little quick house cleaning. These are the Quarkus constructs. I'm injecting what's called an emitter, and it's going to send things out to the Kafka topic barista in. And the way I'm going to find out, so in my inline method, right, the inline method actually calls a method on my order service. What I'm going to do now is incoming annotation means I'm listening to the Kafka topic barista up, and then it's going to call my order service order up, right? So now I'm listening to Kafka, I'm sending something out to Kafka, and I'm listening to Kafka here. Now, to get back to the question about how you do you use a reactive like database driver? Now there is a reactive Hibernate driver and there's a reactive SQL Postgres driver. I'm not using that. I'm using a blocking driver. And so the way I'm doing that is with this annotation here, current thread context and cleared thread context transaction. This is a little bit arcane here, but what this is saying is start a new transaction for this thread, essentially, because the barista is going to be reactive and it's going to execute on its own. So there's a database transaction that started at the web API, and this is going to have a transaction to write a message, and they're going to happen in separate transactions. So what's important, if you can go reactive top to bottom, that's really great. You don't always have that option. I don't think there's drivers for all databases. And for Hibernate, I don't have a driver for all because I'm using Hibernate at the moment. I do have reactive stuff for some, so I can go end-to-end reactive for some things. But if not, you just need to understand where your application needs to be demarcated, right? There's some other things you can do inside of Quarkus. There's a blocking annotation. So various toolkits are all going to have various approaches for that, but you need to understand where it is that your transaction boundaries are going to live, right? So that if you're not going to be reactive, you need to know how to build that into the app. Now I'm going to need to bounce the server for this. So let me bounce the server here. And bounce it with an active transaction. So I've got another instance of Quarkus running, right? So I've already extrapolated a barista application, and that is that's my other application here, Outpost. And Outpost just has the functionality from barista, but ported over into a microservice. So now when I order this, whoops. Whoops. Here, refresh this page. We should expect the same functionality, but what's going to happen is it's going to pop that message onto a Kafka topic, and then it's going to pop it over to my other microservice, which is going to apply the business logic to wait a few seconds, and then stick it back over. We'll do it for cappuccino. Cappuccino takes the longest amount of time. Now, I should ask Michael, what do you like drinking? You like if you were to choose a coffee there. So now we're going cappuccinos. So it took a longer time. Just to make sure I'm not kidding. Come over here. We can see we're creating our drink tickets. So delay time, right? So we have tickets coming in here, right? So now we're using two different applications. So we've successfully scaled out, right? So what we come to now is we extracted a microservice, or we extracted an outpost from our Citadel. So the original monolith application is our Citadel, and the barista now becomes our outpost. And so we can scale that up, right? Especially if we're inside of Kubernetes, right? Makes that super simple to scale that up. We can have tons of instances running. Those are all stateless applications. We can communicate over Kafka really nice and simply. All right, another question? Oh, all right, already answered that one. Chat. We're out of time. All right, so thank you very much. Thank you for having me present today. The slides will be available to you. If you have any questions, feel free to reach out to me by email or any of those channels.